So, hi everyone. Welcome to the 5th edition of Jfokus Brown Bag Lunch. Today, we're going to talk about NewSQL rather than NoSQL. And for that, we have Jon Tirsen with us from, what was it now? Was it Square or was it something else?
Square, yeah. Cash App. That's it.
So,
hi, everyone.
Hi, welcome. So could you tell me a little bit about yourself? Or
I do have a slide for that. Shall I jump straight in with that slide, or?
Yeah, maybe we should start the presentation and we will take it from there then.
Yeah, let's do that.
Welcome.
So you have to forgive me. I'm a little bit. Oh, thank you. Thanks for that. I'm a little bit of a noob when it comes to Zoom, and this is also the first public presentation that I'm doing, kind of the streaming way. So it might all be a little bit awkward, but I'm going to do my best. So I'm going to share my screen and start the presentation like this. And can everybody see that?
Yes, very good, thank you.
Yes, it's all good. So, all right, I'm going to talk a little bit about NewSQL databases. It's going to be a bit of a whirlwind tour because I have about half an hour and it's a pretty big subject. But I hopefully I will also get into a little bit of depth. But first, I'm not nearly famous enough to not require a presentation. So let me just tell you all a little bit about myself. My name is Jon Tirsen. I am originally Swedish, but I've also lived in London, Berlin, and quite a lot in Sydney, Australia. I used to work at these companies, or I have worked at these companies, but I currently work at Square, and specifically at a product called Cash App. These are not very well known in Europe or Sweden, but they're reasonably big in the US. So with that, I'll get started. So at the dawn of time, the 80s, there was SQL, and not just SQL, the language, but the whole idea of the relational database. We had sort of a design methodology and the normal forms. We had various conveniences like joins, aggregations, windowing functions, constraints, ACID transactions, and so on. But we asked more of our database. We wanted to put more stuff in. We wanted to take more stuff out. There was more data and at higher speeds. So these databases, they were convenient, but they were not able to scale very well. So around 2010, there was a counter reaction to this called the NoSQL database movement. These databases, they were simpler, faster, and easier to operate, and could scale out to many database servers. But we sort of lost something along the way. We couldn't rely on strong consistency. We couldn't massage the data into the shapes that we wanted it on the fly. So they were scalable, but they weren't so convenient. I think this is arguable, but I think so. Let's go with that. So there is a new crop of databases that are coming out now, or sort of maturing kind of as we speak. And they're sort of built on the foundations of NoSQL, but they implement a lot of the things that we like about the older SQL databases from the 80s. So they promise to be both convenient and scalable. So let's see if that is true. But first, let's have a look at what NewSQL databases is. So from SQL, we take all these features. From the NoSQL movement, we take the distributed nature, the auto sharding, high scale, and high availability. We take that together. We make all of the SQL features from the left-hand side, we make them global so that they can work on this global large cluster. And then we get a NewSQL database. So I'm not going to do a demo during this talk, but if you want to play around with this as I talk. You can sort of run one. It's very easy to run. In this case, TiDB, and you can kind of play around with that a little bit instead of a demo. What's changed? What's new? Why can we have these things now and we couldn't 10 years ago? Well, first of all, everything these days is just better. I mean, in computing at least. What do I mean by better? So it's faster, cheaper, more reliable, and there's more of it. And what do I mean by everything? So there's networks are more reliable and faster, disks, RAM, CPU, and so on. And we also have new data structures like log structured merge trees, and we have a self-healing infrastructure like Kubernetes, and we have new algorithms like Raft and some of the algorithms for distributed ACID transactions that I'll get into later. Actually not later, let's get into those now. So let's see how these new things that are better lets these NewSQL databases implement something that is hard, which is distributed ACID. I don't know if everybody knows what ACID is. I should have probably explained that, but it's a way to reason about transactions in a database such that they are both atomic, consistent, isolated, and durable. And it just makes it a lot easier to build applications on top of databases that are being used concurrently by many different users or threads at the same time. So NewSQL implements distributed ACID, and there are two popular approaches to doing this right now. Both were invented at Google, and they both use two-phase commit, which has traditionally had issues because of the lack of high availability. So they also use Raft or Paxos for higher availability, and they use these log structured merge trees to be able to read from the past. So again, whirlwind tour. I'm not going to get into the depth here on any of these data structures or algorithms. The two approaches, the first one, and they both deal with how you handle time and the order, the sequence of events in a distributed system. So it's very hard to determine a strong way of determining what has happened before something else in a distributed system. So they have two different approaches to dealing with that issue. The first one is what you could call the spanner style. And in this style, you make sure that the clocks are synchronized between the nodes in different ways. So in Spanner itself, which is a product we'll get into later a little bit, they actually use GPS clocks and hardware clocks, special hardware, to make sure the nodes are very close. The clocks on all of the nodes are very close together. And then they have hardwired sleeps in the commit algorithm, which makes sure that the time that is now has passed in all of the nodes across the cluster. So this approach is used by Spanner and also Cockroach. There's another style, which is called the percolator style, again invented at Google. And in this case, there's a single node called the timestamp oracle, where you go and you basically check out a transaction sequence number, and then you can sort of prove to everyone, well, I started happening before you, so I get to win in this situation. And this is percolator itself is not publicly released by Google. There was just a paper on that, and that approach has been picked up by TiDB as well. So there's another approach that you see in these databases as well, which are not it's not distributed ACID at all, but they kind of have a well-defined local ACID transactions, and this is used by Vitess. And because you know where you have ACID and you know where you don't have it, you can sort of build around that in there. It's not as convenient as these two other styles, but you can sort of work with that. So that's one thing that is kind of new with NewSQL. So another thing that we have now that we couldn't have 10 years ago is that the cap theorem has largely, to some degree, been defeated. And first of all, let me explain what I mean by the cap theorem. You might have heard of it, but I'll just quickly recap, no pun intended. So the cap theorem says that if you have a system and you have these desirable properties, that they should be consistent, should be available, and it should be tolerant for disconnects or partitions, as it's called. You can only pick two of these. You can't pick all three, and this is a proven fact. We can't get around that. But we can't unpick. But to some degree, we've kind of worked our way around it with NewSQL databases, and the reason is that you cannot not pick P. P happens. The world is an imperfect place. Partitions always happen. So you have to pick either A or C. So the NoSQL movement 10 years ago, it picked A. So it wants to be available even in case of partitions. And then you are only eventually consistent. You cannot be strongly consistent. So, something has happened here. So we have better networks. So partitions in general are not as common as they used to be. We have self-healing infrastructure like Kubernetes, and we have better algorithms such as Raft, which means that the impact of a partition is smaller. We can tolerate some partitions, not all of them, but we can tolerate some partitions. And this means that these days you can actually pick CP, and you can be strongly consistent, and you're just not available in case of a catastrophic network partition. And this is this choice works today. It works for probably most applications, not all of them. If you require extremely high availability, this is probably not the right choice. But some of these NewSQL databases, you can tune the consistency, so you can have a eventually consistent read as well. And another thing is that these NewSQL databases, they are actually just built on top of key value stores. And key value stores, you might know, it was really part of the NoSQL movement. So they're kind of cheating a little bit. They usually have a key value layer at the bottom where they store the data and the indexes. And they have sort of a SQL layer on top of that, which is stateless. And you send SQL into the SQL layer, and it plans the query, and it coordinates the execution across these calls out to the key value layer. So you can use all of the kind of experience from the NoSQL movement in scaling out and running key value stores. One exception here is Vitess. Vitess doesn't have the key value at the bottom. They have MySQL databases instead of key value databases. So they are slightly different, but the general architecture is very similar. All right. So now we know a little bit more about what NewSQL can offer us. So when should you use them? So they are new. They have sharp edges that H hasn't worn down yet. They're not as easy to operate, and they sometimes have issues scaling down. So you don't really want to use them for everything, at least not yet. So in which circumstances should you use these databases? So first of all, these are transactional or OLTP online transaction processing, as we database people like to call it, which typically has sort of a latency requirement of 10 to 100 milliseconds. And they can usually, so if you look at the other style analytical queries, they or OLAP, they usually can be run for more than a second or even longer. You don't need a response very quickly. And these databases, they can handle analytical queries as well, reasonably well, but it's probably not the right choice if you're building, say, a data warehouse or something where you primarily need or you only need analytical queries. In that case, there are other solutions that are cheaper and probably more feature-rich and so on. So you want to be a transactional workload for these NewSQL databases. You need a reasonably high scale, and scale has multiple dimensions. So let's break that down a little bit. So you have write throughput, you have read throughput, and you have storage volume. And where does the line go where you want to use NewSQL instead of just a regular SQL database? It's really hard to tell. I should have turned off this this thing. It's hard to tell because writes, different writes are differently expensive. So you need to sorry. So you can have log contention, or you can have write amplification such as indexes and so on. And queries are also differently expensive. So there's not a clear line for writes per second or queries per second. This is just a fuzzy metric. But a byte is a byte. So I kind of have this rule of thumb, and it's a bit of a lame one, is that if you are dealing with more than 1 terabyte, you should look into NewSQL. You possibly might need it. And if you're doing less than 1 terabyte, you probably shouldn't even bother. So that's kind of my rule of thumb. And you should also ask yourself, do you need strong consistency? If you're moving money around, like we do, you probably need strong consistency. If you're dealing with YouTube comments, it probably isn't the end of the world if you drop a few on the floor. But something you should remember here is that it's easier to code against strongly consistent data stores. So even if you might not necessarily need strong consistency for your particular domain, it is easier to write code against it. You should also ask yourself, do you need SQL? So usually you need to have SQL is good if you have a complex domain, if you have some analytical queries mixed in there, or if you need to scale out an existing app that was already built on an existing SQL database, or simply that is what you or your team needs, likes to use, or is used to using. That is also a good reason. But you should plan ahead, because data migrations, and I know this from experience, is very hard and risky and anxiety inducing and scary. So you should, if you think that you might need some of these things in the future, you should probably think carefully about still using a NewSQL database. They are, even if they are harder to operate, they are actually just as easy to develop for. I hope over time that they will become easier to use or to operate, and that we could just kind of have a one-size-fits-all database that you can go to, and it just will be all good. And I think cloud-hosted database as a service products might be one way to address this. So all right, we've determined, do I have everyone with me so far? or have I lost you?
Yes.
You're all there. Okay, good. I can't see you. So what's that?
You don't even see us, right?
No, I have to use the. We're all here. Very good. Okay,
We're
good.
all here.
I'll just keep going then. So we've figured out that we need a NewSQL database, or we want one. What are the issues we might run into on the way? And these are issues I've all learned about the hard way. So one thing that you might want to avoid or could become an issue is what we call a write hotspot. So that's when a lot of writers are very keen to write to one single shard. And this can happen for a few different reasons. Sometimes the data itself has hotspots, or the usage of the data has hotspots. For example, back in the day on Twitter, I didn't work there myself. I just read this in a book. Every time Justin Bieber wrote a tweet, his shard would go down. So this is affectionately called the Bieber shard phenomenon in the literature these days. Another issue you might have is that there are kind of inherent hotspots in the database itself. For example, some of these databases, they use range-based sharding, and which means that if you're not careful, the tail shard, the last shard of the range, might receive a disproportionate amount of writes. So how do you solve this? There are a number of different ways. I think you have to pay attention to it, and then if you're seeing these issues, you have to kind of figure out what to do. For example, I think you could take a dedicated VIP shard for Justin and kind of scale that out vertically. In this case, if you have tail shard issues, you have to hash the input key to spread out the writes, and so on. And there's a number of ways to attack this issue. You also need to. This is kind of the opposite problem of a write hotspot, and it's the issue of fan out. So that's when you have a single statement come in here, and it gets fanned out to a lot of shards. And this can happen on the read side, in which case you get a really wide scatter gather query, or you can also get this on the write side, and if you have a transaction that spans multiple shards, and then you get a really expensive and contentious two-phase commit. And this is the issue here, is that this actually works. It's not, I'm saying avoid. I'm not saying you cannot do this. This is actually not that slow because they kind of run in parallel and so on, but it's expensive in terms of resource usage, and you have availability issues because the total availability on the statement on top is kind of the sum of the availability of the queries that go out to the second layer, and this kind of decreases exponentially as you scale out. So as you grow the cluster, you have to increasingly address these fan outs. And how do you address them? You, in case of a read fan out, they are very similar to a full table scan in a regular relational database. And the way to address them is that you use a global index, so that's stored over there. So you query the index first, and then you query for the data separately. Another way to address this, the issue of fan outs, is something we call entity groups. And then, so if I have a little simple domain model here, we have a customer with some orders, and each order has a line that refers to a product. In this case, you want to co-locate the data, so the customer owns kind of the order and the line, but probably not the product, because that's shared between multiple customers. So depending on the access patterns, you might want to group these together in what we call entity groups. And then you want to make sure that if you chart the storage of the customer data, you put all of the data for the same customer into the same chart. Whereas the products, they might not necessarily be charted at all because there's not enough of them. So in this way, you can kind of, both when you query the data and when you update the data, you only have to go, if you're dealing with a single customer, which might be the most common case for your system, you might only need to touch a single chart. And depending on the product, the database you're using, you have to do this in different ways. So Spanner and Cockroach, they have something called interleaved tables that lets you do this. In Vitess, you would pick the right charting column to achieve this, and TiDB doesn't actually support this type of colocation yet. It's coming with the next version, which is coming next year. Then we know a bunch of stuff about NewSQL. So let me also then just quickly go through some of the products that are kind of part of this movement and implement these ideas. So first of all, we have Cloud Spanner from Google. This is it's kind of the gold standard. It really has probably the richest feature set of all of these. But it's only available in the Google Cloud, and it is allegedly very expensive. There is also Vitess, which we use quite heavily. We rely on very heavily. And it's built on top of MySQL, as I mentioned before, and it really kind of started out as a way to manage large fleets of MySQL, and it's kind of grown NewSQL-like capabilities. But because the way it's built on top of MySQL, it probably can't ever get all the way to where some of these other products are. So we're also looking a little bit at TiDB, which is compatible with MySQL. And there's also Cockroach, which is compatible with Postgres. And then there's Gigabyte, which often get mentioned in these contexts, but I don't actually know all that much about that. So that was NewSQL. To summarize, NewSQL is scalable SQL built on recent innovations. You should use it to scale out transactional workloads, and you should pay attention to write hotspots and fan outs. And that's it for me. Thank you. Those are my internet coordinates. And I think we can take some questions now.
Perfect. Thank you. I guess if you're not sharing your screen, then we will all be back here. And I will stop the recording first. Thank you very much, Jon.
Thank you.
Very good. Very good.